Okay students, so in the previous videos we have discussed about local maxima, local minima, absolute maxima, absolute minima and our first and second derivative test. Today we will solve some problems based on maxima and minima. So here we have some questions. We have to find absolute maximum and absolute minimum value of function sin x plus cos x and in the interval 0 to pi, and 4x minus half times of x square in the interval minus 2 to 9 by 2. Okay, we need absolute maximum and absolute minimum value of function. So to find absolute maximum and absolute minimum value, first we need critical point of f. Critical point means the point at which derivative of function becomes 0 or derivative does not exist. So for that, first we'll differentiate. We have f of x equal to sin x plus cos x. We differentiate, then we get cos x minus sin x, and a derivative, you know that derivative of sin and cos. So this is our first derivative. Now if average of x becomes 0, then we get our critical point. So if it is 0, then cos x minus sin x is 0. It means cos x equal to sin x, and if we divide by cos or sin, if we divide by cos we get 1 equal to tan x, or if we divide by sin we get cot x equal to 1. So in both the cases, okay, this implies tan x equal to 1 by dividing cos x. Now tan x is 1, so x should be in this interval. Tan value of tan is 1, means for pi by 4 tan will be 1, so x is pi by 4. In the interval 0 to pi we have only one value. This interval means first and second quadrant, so tan will be 1 only in the first quadrant, means x will be pi by 4. So this is our critical point. Okay, only one point we have critical point. Now what we'll do, we find value of function at this critical point and at the ends of this given interval. Okay, to find absolute maximum or absolute minimum value, first we need critical points, then we find value of function at this critical point as well as this is the end of the interval. So now f of pi of 4, value of function at pi of 4 will be sin pi of 4 plus cos pi of 4. Its value 1 by root 2. Both cos and sin have same value for pi of 4. So 1 by root 2 by root 2 is 2 by root 2, that is root 2. Then f of 0, value of function at 0. So sin 0 plus cos 0. Sin 0 is 0, cos 0 is 1. So value of function at 0 is 1. Now at pi, cos pi plus sin pi. Cos pi is minus 1, sin pi is 0. Okay? So we have values root 2, 1, minus 1. Which is greatest? Root 2 is greatest one, minimum value minus 1. So absolute maximum value of function, absolute maximum value is root 2 and absolute minimum value is minus 1. Okay? Root 2 is absolute maximum value, minus 1 is the absolute minimum value. So what are the steps? First find derivative function, first derivative, then find critical points, means put derivative equal to 0 and simplify, solve the equation. Okay? You have to find x between these values. Okay? Maybe one value, maybe two values, maybe three values, depends on the given function and interval. Then we find values of function at the end of the interval and at critical points. Then we'll see the maximum and minimum value. The maximum value will be our absolute maximum value, minimum value will be absolute minimum value. Okay? Now in this question f of x is given 4x minus half x square and interval is minus 2 to 9 by 2. Sorry, so first we find derivative of function, that will be 4 minus 2x by 2 means 4 minus x. So critical point, if f is 0, then this implies or 4 minus x is 0, means x equal to 4. So again we have one critical point 4 and 4 lies between these two. So now we find value of function at these 3 points, at minus 2. So 4 into minus 2 minus half times of minus 2 square. So it will be minus 8 minus 2, that is minus 10. Then f of 9 by 2, so 4 times of 9 by 2 minus half times of 9 by 2 square means 81 by 4. So it is 18 minus 81 by 8. By similar 18 8s are 144 minus 81 upon 8. That will give you 14 minus 8 63 by 8. Then f of 4 into 4 minus half times of 4 square. So it will give you 16 minus 16 by 2 8. It is 8. So here minus 10, 63 by 8 and 8. Minus 10 minimum value, 63 by 8 is less than 8 and 64. So here absolute maximum value is 8 and absolute minimum value will be minus 10. It is maximum value, it is minimum value. So to find absolute maximum or absolute minimum value, just find first derivative, put it equal to 0, find the critical points, then value a function at all the critical points and at the end of the given interval, and you can see which is the greatest and minimum value. That will be our absolute maximum, absolute minimum value. Okay, and these points will be point of critical points can be point of local maxima, local minima. Okay.